This is the Raspberry Pi Pico board. This is the Raspberry Pi RP2040, which is their new dual-core Cortex M0 chip that they've just released. And it's a bit of a weird chip, if I'm honest. Firstly, it's dual-core Cortex M0 Plus, which isn't completely alien, but you don't see many of them. And then at the same time, it doesn't have any onboard flash, which is a bit of a first for a Cortex M0, as far as I'm aware. I'm sure that there are microcontrollers out there that are like that, but there's sort of the sort of thing you'd see on like a Cortex M4 or a Cortex M7, not on a Cortex M0. So the reason it's called an RP2040, according to the datasheet, is because it is a Raspberry Pi, makes sense. 2 for the number of cores, 0 for the type of core, so it's obviously an M0 Plus, so it's 0. And then the 4 and the 0 refer to they basically refer to the RAM and the amount of non-volatile memory. So the 4 is because it's got 264 kilobytes of SRAM, and 0 because it's got no flash on board. That is one of the weird things, though. You don't see many Cortex M0 devices that have got 264 kilobytes of RAM. Ordinarily, I guess you'd see something more like 48 or 64. So that's quite an interesting one as well. And then the Pico itself gives a USB interface directly to the Raspberry Pi, and then it's also got a load of power stuff and a crystal, but otherwise there's not a fat lot else. Interestingly, when I bought this, it came as on a tape, ready to go in a pick and place machine, and the pins along the edge are designed so that you can solder it onto a PCB if you wanted to use it as a sort of system on module, but there's not a fat lot to it, so I don't know what benefit you would get to just soldering down a QFN in the first place, which is obviously what the RP2040 actually is. Another thing that's weird is that the USB interface on it is a USB 1.1, which is weird. That's slow. I mean, it's 2021. I would have expected it to be USB 2. If I compare it to something like the SAMD21, I think most Maker devices that are Cortex M0 are the SAMD21. So the Arduino Maker family is all based on the SAMD21. The Adafruit Feather uses the SAMD21, and the SparkFun Redboard also uses the SAMD21. And then also in comparison, we've got the STM32L0, which is their sort of ultra low power Cortex M0. And there's such a stark difference that it makes me wonder if Raspberry Pi have a customer in mind that this is tailored to, and that's the reason why they've gone for such weird specs, particularly in not having any onboard flash. So the Pico, I should mention as well, the Pico does come with a flash chip as well. I don't remember what it was now. How much is it? Oh, here we go. So the Pico comes with 2 megabytes of onboard flash. That's a fairly substantial amount of flash for a Cortex M0 anyway. And then basic other Cortex M0 stuff, so UART, SPI, I2C, 12-bit ADC, none of that's new at this point. It's sort of to be expected, but it's such a weird chip. I can't work out why they would go with, firstly, USB 1.1, and secondly, a dual-core Cortex M0 without any onboard flash. It's sort of like a crappy Cortex M4. The fact that it can run up to 133 megahertz, and Cortex M4s, that's the sort of speed you'd be expecting from a Cortex M4. It being dual core, I think, is interesting because you don't see many Cortex M0s that are dual core, but it doesn't need to be dual core. If you had a fast Cortex M4, it could quite easily do it. And the other thing is, obviously Cortex M0s are usually marketed as an ultra low power, low speed, sort of like a high-end 8-bit micro, but they usually run at very low power. And I was looking through the specs on this, and the lowest power it consumes in dormant is 180 microamps, which is massive. That's not even low power, to be honest. The sleep mode is 390 microamps. So dormant, I'm assuming, is like the lowest power state that it could go into. So ordinarily, Cortex M0s that go down into that low power mode, they can only be woken up either with the RTC, something from the backup power domain that will allow it to wake up, or it'll just be a physical change on the reset line, so clicking the reset button basically. And usually, I mean, the SAMD21 goes down to something like 700 nanoamps or 600 nanoamps depending on how you're running it. And then even the sleep mode on the SAMD21 is like 5 or 6 microamps, again, depending on how you're running it. And the sleep mode can usually be woken up with external interrupts and that kind of thing. So the fact that the sleep mode on this is, or rather the dormant mode, is 180 microamps, that's really bad.